We open a page of the Google server. Let's say I'm searching for a word now. You will find that there are many corresponding options below. That is, I am now searching for it through the web. Then please pay attention. It's different, like some options are actually different subprocesses. That is actually for them. You are accessing the server of Google, but you are accessing a different process in the Google server. So it is equivalent to, although you are also accessing the server of Google now, but actually for your device. In fact, your current device, different processes are started. They are all Google. That's for the port number. The port of our transport layer. It can only be based on our service, or positioning based on application. So what exactly is this service? It can't be done. How do you do it? Let's move on to the session layer. The session layer can realize our different application processes. That is, the distinction between service processes and service processes. It's enough for you to understand. For the process. In fact, it is also a process, but it's a subservice in the process. There are still some differences. That is, strictly speaking, a process that everyone understands. In fact, in our broad sense, a concept of service. But for the process, it also differentiates between subservices in a process, or subprocess. Then for it, our transport layer can't do it. Need to use session layer. Looking further up, there is a layer called the presentation layer. The presentation layer is responsible for compiling and decoding data. For example, suppose I'm on the left and this is a PC. Then this PC assumes that the installed system is a Windows system. Under Windows, we can actually implement software-to-software communication. First, you need to know both PCs are Windows system, able to communicate with each other. Everybody knows. Now the server is actually based on Linux system. We're going to knock orders with Cisco's equipment in the future. Actually, we are using Cisco iOS system. It is also a secondary modification based on Linux. So in fact, 4 different systems. They all have differences between the underlying systems. Like me now. I downloaded a Windows system on the PC side of my device. Installed a WhatsApp. For example, the PC here. I'm on a desktop version of Linux. Also installed a WhatsApp. So even for the same software as WhatsApp, but it's actually a different underlying operating system. That is for us. Even if our underlying architecture is different. But in fact, everyone knows it doesn't affect our communication with each other. Then here comes the problem. Data encoding format under our Windows. That is, the encoding format of WhatsApp. It is different from the Linux system. Then if the encoding form, under different circumstances, data looks different. How did you communicate? That is, how do you connect future data? There will be a session layer among us. It will be dedicated to compiling and decoding our data. Then put our different underlying systems under all data. Convert to a standard format. Communicate based on the middle. It's like people going to translate the language of a country. Become a universal language. We all translate into a standard language. Communication is the same. Let's just understand. That is, we can implement between different operating systems in different underlying environments. It will not affect the data of the upper application software. I can convert the representation to a generic standard encoding format. This is our 6th floor. The last one is our 7-layer application layer. The application layer actually implements relatively many functions. Let's start with the first function. The application layer is the first to bear the brunt of the problem to be solved. It's the problem that the lower models can't solve. I just mentioned to you. I say if the future is at the transport layer. We use a protocol like UDP. In fact, it has no way to complete the data retransmission. If a data fails the data link layer check. Then if the 4 layers choose TCP, it is capable of retransmission. If it is UDP, it cannot be retransmitted. For example, we are now a WeChat chat box. I am sending data to others now. If at some point my internet is not very good, then there will be a red exclamation mark in front of the message. After we artificially click on this exclamation mark, data will be resent. That is to say, for our data, if I am within the stipulated time, I didn't send this data. It is equivalent to my sending failed. I don't automatically send. That is to say, these agreements we are now following, or the lower level, it can't solve this problem. Then only by means of this application. Develop an exclamation mark here. Such a button. Make you click this button artificially. As long as you automatically resend the data for you. This is equivalent to a retransmission of the data. That is, your data is in the process of transmission. Due to network problems, there was a problem with the data transfer. But this data will not be in the situation that the network gets better again. Automatically deliver for you. We cannot retransmit. We all retransmit manually. Then, for the lower level. If you are chatting on WeChat now, the protocol we choose now is UDP. Automatic retransmission is not possible. Application layer. Develop some tools. That is, some means of access. Help you achieve retransmission. Is to rely on manual resending. This is called an error correction process. At the application software level. If for you during the video, network stuck for a while, it can't be passed. Because for video, this timely flow. If you lose it, lose it. No need to retransmit. So different business flows. There will be some different standards in the future. So does this thing need to be retransmitted? Are defined by the software. Like WeChat thinks you are sending data. Or some voice messages sent. Is capable of retransmission. Then they provide the corresponding button. If you are making a voice call. If several packets are lost in it. Network stuck a few times. They see no need for retransmission. They won't give you corresponding retransmission measures. Then you lose this data and lose it completely. This is our reference model for OSI. In addition to this function, the application layer. And others. For example, different data can be generated. Are different programs in the future. Or between different applications. Our data are all different. I sent a message on WhatsApp. What I generate is based on the data generated by the WhatsApp application. WhatsApp it will conform to some of the specifications of an application like WhatsApp. That is, the specifications made by some applications. Between the different applications, specifications are different. Based on our current application layer. Can generate different data. And one last point. It's our authentication or encryption method. Actually for authentication and encryption, we prefer to refer to the large application layer. Actually for a function like this. In fact, we still follow the overall TCP/IP standard. What we call the function implemented by the large application layer. For example, account password. All are based on the verification methods set by our large application layer. Then provide you with an identity verification in the future. Here's what we're talking about. Last encryption. Speaking of which, let's make a summary. We are now a 7-tier architecture. In the 7 layers. Each layer is able to implement the problems of each layer. In other words, it can solve the problem of each layer. The physical layer solves the transmission medium pair. The physical layer connects devices. Transmit our data signals. Then the data link layer. We have 2 more important parameters. A MAC address. Another is to provide the function of error detection. For the network layer, there is a core parameter called IP address. Secondly, there is a function called routing. There are 2 major protocols at the transport layer. One is TCP and the other is UDP. We have another protocol station called TCP/IP. In fact, it is the TCP protocol used at the transport layer. And network layer IP protocol. IP protocol is called Internet Protocol. And our transport layer, what we call the TCP protocol. 2 major protocols make up such a name. This is our transmission control protocol. What we are using now. In fact, it is the protocol station of IPv4. That is for us now. These 2 agreements are very large. Represents the core of our entire data communication learning. The 2 most powerful agreements. Everyone is relatively familiar with the IP protocol. Everyone is unfamiliar with TCP. The overall development cycle of the TCP protocol is about 20 years. It can achieve a lot of functions in it. The overall development cycle and design cycle are very long. Actually, we as networkers. In fact, only about half of the knowledge in TCP can be accessed. The remaining half is for programmers to touch. So such an agreement. Don't ask everyone to fully grasp. Even if you get to IE. You can't learn all the functions of TCP as a whole. So what we are more important is to revolve around us on the 2nd and 3rd floors. To discuss our overall web technology. Of course, the transport layer is also very important. But relatively speaking, there are not as many as the 2nd and 3rd floors. Based on the 7 layers of our current OSI reference model. Each layer it can solve the problem of each layer. So the final question. The development cycle of a program is relatively long. Then each layer. It has to choose a specified protocol. Then in theory our application is developed as a whole. If you now go up layer by layer to the application layer, there is one more problem that has not been solved. So basically this app or this service don't go online because it is inherently problematic. In theory, as long as it reaches the application layer, everything in your app, it should have been resolved. Also known as the bug of this software. So sometimes you will find some software needs to be updated all the time. Been going to fix some bugs before. There are some problems during development. Routers and switches are really in terms of devices. There is no essential difference. The difference between them is, from my current point of view, they work differently. For the switches we are talking about now, it can be understood as our layer 2 switch. It works on our data link layer. That is, for a layer 2 switch, it can only process information that sees at most our data link layer. A data to a switch. This packet can only be split to the 2nd layer at most. The contents of the 3rd floor cannot be seen. That is, in this data, all the IPs it offers, including some addressing forwarding. The protocol used by the 4-layer delivery layer. I don't see any of these. I only look at the content in the data link layer. Data forwarding based on IP address. For layer 3, the router receives the data. After the second floor, I will see the third floor. In layer 3, I will check the source IP and destination IP, and query the routing table for forwarding. Switches and routers. At this stage we are. First, the levels of the packets they view are different. It works on the second floor. It works on 3 layers. It sees that packets are split to layer 2. It sees the packets are split into 3 layers. It is based on the MAC address table. Perform data forwarding on the chain. It provides data forwarding throughout network communication based on routing. Because query routing. It's another level. It's not the same concept as our second floor. So just tell everyone. There is no essential difference between a switch and a router.